This is experiment 21 RC circuits. First thing we're going to do is, this should already be set up. We're going to, before we do anything, discharge our power source. So we're going to take this paper clip and we're just going to put it between both sides of the power source to discharge it. And that's all we're doing there. And then we are going to turn this on. It's actually not quite set up right now because we don't want to mess up our graph, which is already pretty. But you're going to turn this on, and then all you're going to do is just take this and put it down and leave it down for about 10 seconds. While that's going on, this curve should go up and make this shape. So wait until it gets to about, like, I don't know, it starts flattening out really nicely. And then after that, you just go ahead and stop your taking data, and you can just flip this thing back up. It doesn't matter. Then, what you are going to do is you are going to take this little cursor dude, and you are going to find, why can I not move this? Well, you're going to find your max value, there we go, which should be this number. We're going to look at the y-axis, so 5.484.
She moved it to where it flattens out.
Yes, where it flattens. And we're going to take this and we're going to multiply that by 0.62. So the 5 number was our v at infinity, where it flattens out, the velocity where it flattens out. And we're going to multiply this by 0.62 to get what our half-life should be on the curve of the...
But could you please grade that as though?
So once we find our half-life, which in our case is about 3.4-ish,
No, I don't want to take that.
we're going to take this and bring it to the point on the curve where it matches the half-life, which in our case is about like here, about 3.4. So your x is going to match your half-life, which again is 0.62 times the v at infinity. Once you find that point, your x value is going to be the same thing as your delta t. That's it. That is your x value. That is your delta t. Then you will see if that delta t, the experimental delta t, matches r times c. It should be the same thing as r times c plus or minus 5%. That's pretty easy to do. Your r should be given, which would be 5100, and your C should be in farads, and it should be written on the capacitor dude right there somewhere. It should be written on there. I believe it's upside down. And you're just going to multiply this out, and then basically just see if it fits within 0.5 or within 5%, and then you just see if it's works. And that is it for that part. Then you're also going to look at your C fit and see if your C fit is equal to 1 over r times c. Your C fit
and what was C fit?
C fit experimental is this number right here. You see C exponent 8, so 0.865. That is our C fit.
When we got that, this over here came from going
fit.
to fit and going to inverse exponent fit, which gives you this box. And then that 0.865 is our CFIT.
Yes.
That's theoretical CFIT.
Actually, that's experimental. Theoretical will be 1 over RC.
Yes.
Yes. So we see if our experimental, which is, again, the 0.865 number, equals 1 over RC. RC is the exact same thing as last time, the 5100 number times the 225 microfarads, which we got, again, from the blue thing. And we just see if it's within 5% of that, which in our case it was, which is good. And that is the entire Lab 21.